Let's learn everything under the sun because Science 10 is fun. Hi, I'm Christian Mercado from 10 Graciousness. In this video, we're gonna talk about plate boundaries. As a recap, we talk about plate tectonics and its relationship to the distribution of earthquake epicenter, active volcanoes, and major mountain ranges. Before we start, let's take a look at this picture. Yes, this is a jigsaw puzzle. In some ways, our planet Earth resembles a giant jigsaw puzzle. Why do you think so? It's because the Earth's outer surface is composed of tectonic plates, which are enormous sections of the planet's crust that roughly fit together and meet at the places called plate boundaries. Plate boundaries are the lines at the edges of the different pieces of lithosphere. There are two types of crust. First one is continental crust, thicker but less dense. And the next one is the oceanic crust, thinner but denser. The Earth's lithosphere is moving constantly and slowly because it's riding on the warmer and softer layer called the asthenosphere. This movement causes the formation of plate boundaries. The convergent, divergent, and transform plate boundaries. Let's first identify what is the thing we called convergent plate boundaries. Convergent plate boundaries is when the crusts come together or move towards each other. There are three types of convergent plate boundaries. We have oceanic to continental convergence, oceanic to oceanic convergence, and continental to continental convergence. Oceanic to continental plate. This happens when the denser oceanic plate collide with the less dense continental plate. When the collision happens, the denser oceanic crust undergoes what we call subduction process. Subduction refers to the bending of Earth's crust towards the mantle. As you can see in the picture, the oceanic crust subduct under the continental crust. As the oceanic plates melts at the upper layer of mantle, it becomes magma, rises and reach the crust and causing volcanic activities on the continental leading plates. Also, you can see in the picture what will form if this event occurs. Let's move on to oceanic plate to oceanic plate. This happens when one oceanic crust subducts to another oceanic crust. As you can see at the picture, the subduction process occurs in this type of convergence. Also, you can see an older oceanic crust and younger oceanic crust. Older oceanic crust will subduct through the younger oceanic crust because older oceanic crust is denser than the younger oceanic crust. The features of subduction zone are the same with the oceanic to continental subduction zone. The subducted materials also melts and forms magma and rises towards the surface of the ocean, forming volcanoes. In this case, the line of volcanoes that grows on the upper oceanic plate parallel to the trench is an island arc. Converging oceanic plates will also cause formation of trenches, and these trenches will become causes or sources of earthquakes. Continental to continental plates convergence. It is when the continental plate collides to another continental plate. When two continental plates converge, a collision zone is formed. Since subduction is impossible between two colliding continental plates, pressure is released by pushing the crust upward, forming mountains. No trench, no volcano, and no island arc are formed. What is created is a group of tall mountains called mountain ranges. So we are done to the convergent plate boundaries. Let's move on to divergent plate boundaries. Divergent plate boundaries is when the plates pull away or separate from each other. From the word itself, diverge. There are two types of divergent plate boundaries: continental to continental divergence and oceanic to oceanic divergence. Let's start in continental to continental plate divergence. It is when the two continental plates diverge or move away from each other. It's also known as continental rifting. This leads to the formation of Rift Valley and later on becomes new ocean basin. Molten rocks from the mantle erupts along the opening, forming new crust. Divergent plate boundaries rift a continent apart. Eventually, a new ocean will form between the two continents. Moving on to oceanic divergence. It is when two oceanic plates diverge or move away from each other. It forms a mid-ocean ridge or mid-oceanic ridge. It's an underwater mountain range formed by oceanic plates moving apart. As this happens, plates move apart at mid-ocean ridges, lava rises upwards, erupts, and cools. Later, more lava erupts and pushes the original seafloor outward. This is seafloor spreading. Seafloor spreading forms new oceanic crust. The rising magma causes the ridge to be buoyant. The plates pulling apart cause earthquakes. So we are done to the divergent plate boundaries. Let's move on to the last one, transform plate boundaries. Transform plate boundaries is when the two plates slide horizontally past each other. They are also called conservative boundaries because crust is neither destroyed nor created along them. Transform fault boundaries are the most common on the seafloor, where they form oceanic fractures zone. When they occur on land, they produce faults. Oceanic fracture zone form large valleys or trenches that connects spreading oceanic ridges. I'm gonna sum it up before ending this video. So now we know what's plate boundaries, 3 types of plate boundaries, and the difference in convergent, divergent, and transform plate boundaries. This is the end of my video, and thank you for watching.